Let's talk about the derivative of secant. If you've been watching this series, then you probably have some idea about what we're going to do. I'm going to do this derivation from the perspective that you already know, the derivative of sinus cosine, the derivative of cosinus negative sine, as well as a few reciprocal identities back from trigonometry days of life. But outside of that, it's pretty straightforward. So here we go, let's do it. So guys, the derivative of secant, well, let's think of secant in terms of its reciprocal identity of 1 over cosine, because I actually know cosine's derivative. And so I'm going to replace the secant there. And well, the derivative of a quotient is obviously quotient rule, so let's apply quotient rule and we get this expression. So again, bottom times the derivative of your top function minus your top function times the derivative of your bottom, all over the bottom function squared. And we can actually clean this up quite a bit. The derivative of, well, 1 is obviously 0, and the derivative of cosine is, like we said before, negative sine. So let's replace those two derivatives in that numerator. And 0 times anything is just 0, so that entire numerator can be cleaned up as well. That these two negatives can be combined, and so now we get this expression. In the denominator, you'll notice that we have a cosine squared, which just simply means cosine times cosine. So I'm going to rethink of that denominator that way. And then I can break up that as the product of two fractions, 1 over cosine times sine over cosine. Looking at it from that perspective, well, now we can hopefully understand why teachers commonly report the derivative of secant as secant tangent. Have a great day, nerds.